Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pickar, working on Unit 2 Notes, Video 3, Solving Absolute Value Equations, and we want you to be able to identify and solve absolute value equations. So, absolute value of a number is its distance away from 0 on the number line. So we had a number line like this, where 0 is in the middle. If you went over to, we'll say, 3. The distance between 0 and 3 is 3 units on the number line. Now, that's positive. If you went negative 1, 2, 3, let's say negative 4. Well, negative 4 to 0 on the number line, if you count, it's 1, 2, 3, it's 4 units. Distance is always positive. So when you're working with absolute value, no matter what the number is, when you take the absolute value of it, you make it positive. For example, over here, absolute value of x represents the absolute value of the number x. Here we have the absolute value of 7. Well, 0 to 7 on the number line is 7 units. 0 to negative 7 on the number line is also 7 units. So whenever you take the absolute value of a number, you make it positive. When solving expressions over here now, the absolute value bars act like, kind of like parentheses, perform as many operations inside the absolute value bars first. So basically down to one number. So if I had something like simple like 3 minus 5 in the absolute value, we'll say plus 8, whatever. Well, you have to do everything inside here first. Now, a lot of people think, well, that's a negative 5, you have to make it positive. No, you got to get it down to one number first, so you have to perform the operation inside there. 3 minus 5 is negative 2 plus 8. Now we take the absolute value of it because we got it down to one number. Absolute value of negative 2 is 2. 2 plus 8 is going to give us 10. Okay? So that's kind of how you work with these absolute value bars. Let's take this one down here. Try this one out a little bit. Bring this one down here. Anyway. So we got 1.4 on the outside. We're going to add that to whatever is inside this absolute value. You have to do all the work inside there first. Don't make this negative 7 positive. Don't make the negative 3 positive. Just evaluate it down to one number, then take the absolute value of it. So 1.4 plus, first I'm going to multiply these two. That's going to be 5 times negative 3 is negative 15 minus 7. 1.4 plus. Negative 15 minus 7 now is going to give me negative 22. Now I can take the absolute value of it because it's down to one number. 1.4 plus just 22. And 1.4 plus 22 is, what do we got? 23.4. You can try, I better do this one too because it's a little different. Okay, now we have a negative outside this absolute value right here. So we're going to do the work inside the absolute value, but once we take the absolute value, we make it positive. Then we multiply it by this negative 1 on the outside. So whenever there's a negative in front of an absolute value, you're going to have a negative number there. But just doing the work, negative 4 plus 21 is going to give me negative the absolute value of 17 plus 6.2. The absolute value of 17 is 17. So I'm just going to put it in parentheses now. Now it's negative 1 basically times this 17. So that becomes negative 17 plus 6.2. Negative 17 and 6.2 is going to give me negative 10.8. And that's my final answer there. Okay. So a little work with evaluating. Solving absolute value equations is almost the exact same as solving regular equations with one major difference. Okay, we're going to be, whenever you take the absolute value of something, you get a positive answer and a negative answer. So you're going to have, in most cases, 2 solutions. So what would x have to be to make this statement true? Well, right here, for this one, absolute value of x equals 5. Well, if x is equal to 5, the absolute value of 5 is 5. Also, this x right here, if it was negative 5, the absolute value of negative 5 is positive 5, so you can say x equals also negative 5. If you're looking at this on the number line, here's 0, here's 5. What's the distance between those two? 5. This 5 right here. Here's 0, here's negative 5. What's what's the distance between the two of them? 5. So when we take the absolute value of 5 and negative 5, we're going to get positive 5. So in essence, you end up with two answers, a positive answer and a negative answer. Now this one over here, some people would say, oh, that's equal to 3 and negative 3. But if I take the absolute value of 3, it's never going to equal negative 3. So even if I made this a negative 3 inside here, when I take the absolute value of it, I make it positive. So whenever you isolate your absolute value like this and it's equal to a negative number, this is no solution. Can't be done. Okay, so we'll talk about that a little bit more in these next couple problems. So solving absolute value equations. Okay, there's two things. Isolate the absolute value. That means we're going to get this whole thing by itself. We have to get rid of this negative 3, get the absolute value and everything inside it by itself. And then split into two separate equations, one equal to the positive number and one equal to the negative number to get your two equations. So bringing this down right here, it says step 1, isolate the absolute value. It's kind of like getting x by itself, but now we're getting the absolute value by itself. So right here, like I said, we got to get this by itself before we can actually set it up in the two equations. So we're going to add 3 to both sides because it's not in the absolute value. So absolute value of 2x plus 6 equals, in this case, 16. Okay, so number 2, it says to split up the two equations. Basically, what I'm trying to say is, let's say we just cover this up. What could be inside this absolute value that would, if you took the absolute value of it, it would equal 16? Well, you could have a 16 in there. Absolute value 16 is 16. And the absolute value of negative 16 is also 16. So basically what I'm trying to say is 2x plus 6 could equal negative 16, and 2x plus 6 right here could equal positive 16. You usually do the positive first and the negative second, but it really doesn't matter. You just basically got to take everything inside there now and set it equal to 16, right here, the positive part, and set it equal to also negative 16, the negative part of that answer. And then solve these two equations, and that's pretty much it. Now we're just going to solve them like you would solve a regular equation because we've pretty much taken them out of the absolute value. Subtracting 6 from both sides. 2x equals negative 22. And dividing by 2, our first answer is x equals negative 11. When you're working with absolute value, you're almost always going to get two answers. One when you set equal to negative 16, one when you set equal to positive 16. Subtracting 6 here, I'm going to get 2x equals 10, and then divide both sides by 2. X equals 5. There are my two answers, negative 11 and 5. If you plug these into the original equation for x and simplified it down, you should get 13 for both of them. So you can also check your work. Okay, solve the absolute value equations. First step, isolate the absolute value. This one's already isolated. And it's equal to a positive number, that's key. If it's equal to a negative number, it's not going to work. So basically take b plus 15, everything inside there, and set it equal to that positive number 3 and the negative. And this is where you're going to get your two answers. Okay. Now we'll just solve for b in both cases. Subtracting 15, I get b equals negative 12. Also, subtracting 15 from both sides, I get b equals negative 18. And those are your two answers. If you plugged them in up here, like negative 12. Let's just try that real quick. Negative 12 plus 15 is 3. The absolute value of 3 is 3. If I plug in negative 18 plus 15, negative 18 plus 15, that's equal to negative 3, but the absolute value of it is equal to positive 3. So that's kind of how you check your work a little bit. This problem over here, isolate your absolute value. So we got to subtract 4 from both sides. When I do that, 3n plus 2, absolute value of that equals negative 4. Okay? So you isolated your absolute value, it's by itself, but it's equal to a negative number. Is that possible? Well, can I ever take the absolute value of something and have it equal to a negative 4? No. If I plugged in 4 in there, the absolute value of that is 4, not negative 4, so it doesn't work. This, when it's equal to a negative number like this, when you got the absolute value isolated, this is, once again, no solution. Couple steps here. Now, a lot of people might want to distribute here. With absolute value, I don't do that. You always kind of leave your absolute value by itself. Isolate it, get it by itself. So you're multiplying it by 3 and adding 4. So what I would do first here is just subtract 4 from both sides. Now, sometimes when you distribute that, like the 3 through there, it might work, but it doesn't work all the time. So what I would do in this case, you're multiplying by 3. The opposite would be to divide both sides by 3. Kind of treat this like just the variable x and get it by itself. Absolute value of x plus 5 equals, in this case, 4. Okay, that's a positive 4. So we can go ahead and break this problem up into 2 equations and solve. What that means is x plus 5 could equal what 2 things? Could equal 4, or the opposite of that. If I took the absolute value of negative 4, that would equal 4. So I can set it equal to negative 4 also. Those are the 2 equations I set up, positive, negative. Subtracting 5 from both sides, I'm going to get x equals negative 1. Also, subtracting 5 from both sides, I'm going to get x equals negative 9. Those are my 2 answers. Absolute value equations, 99.9% of the time have 2 answers. Okay, number 4 over here now. The absolute value is already isolated. It's equal to a positive number, so we're going to get 2 answers here. It's not a no solution. I can say everything inside here, 2/3 x plus 6 equals 2. And I can also say 2/3 x plus 6 equals negative 2. And then these are the 2 equations we would solve. I'm going to take care of this fraction 2/3 after I get rid of the negative 6. We're going to subtract 6 from both sides actually. 2/3 x equals negative 4. There's a couple different ways you can do the fraction. You could multiply both sides by its reciprocal, 3/2, like this. But I just kind of make it, I think it's a little simpler. You can do it either way. You're multiplying by 2 basically, and you're dividing x by 3. So I'd multiply both sides by 3/1 or just 3. That'll cancel out this 3, and you're left with 2x equals negative 12. Divide both sides by 2. X equals negative 6. There's one of my answers. Over here, I'll do it in red. What do we got? Subtract 6 again. This is all one term, so you want to get that variable term by itself. Negative 2 and negative 6, I get 2/3 x equals negative 8. Once again, it's a fraction, so I'm going to multiply both sides by 3/1, or 3. These 3's cancel out. I get 2x equals negative 8 times 3 is negative 24, and then divide both sides by 2, and I get x equals negative 12. So these are my 2 answers, negative 6 and negative 12. Good to go. So working with fractions there a little bit. Here's another one with fractions. We'll bring 6 down here. We'll work with this one up here. Okay, the absolute value right here is isolated. It's equal to a positive 16, so I can bust this up into 2 equations right away. 10 minus 3/4 x equals 16, first of all, and 10 minus 3/4 x equals negative 16. Bring that over there. Okay. I got this negative 3/4 x, so I'm going to get rid of the 10. Now I see the subtraction here, and some people think, well, I got to subtract 10 from both sides. This 10 is positive, so I do subtract 10 from both sides because it's positive 10. Negative 3/4 x equals 16 and negative 10 is basically 6. Okay. It's a fraction again. I'm going to get rid of the 4 first of all. I'm going to multiply both sides by 4 over 1. The 4's will cancel out. And multiplying by 4 on that side, I get 24. So negative 3x equals 24. Divide both sides by negative 3. X equals negative 8. Subtracting 10 again from both sides, I get negative 3/4 x equals negative 26. Okay, a little bit bigger numbers here now. Multiply both sides by 4 over 1, or just 4. Cancel out. Negative 3x equals negative 26 times positive 4 is negative 104. And divide both sides by negative 3. You could say x equals 104 over 3. Negative divided by negative is positive. But if you divide it out, you get positive 34.6 repeating. Or you could round it and say 34.7 if you wanted to. Either one of these answers would be just fine with me. So negative 8 and 34.7. So let's try this one now. Give ourselves a little room. Okay, absolute value is isolated. It's equal to negative 36. Can I ever take the absolute value of some number and have it equal a negative number? No. If this was positive 36, I'd break it up into the two equations right away. But being it's equal to negative 36, no solution. If you think you got it, you can kind of move on now. This one's a little bit more complex, so I might stick around for at least this one anyway. Here's x. It's inside the absolute value. This is the absolute value equation. It should have two answers. I got to do a little bit of work here. I got to get this absolute value isolated. Now, you might think you'd multiply by both 7s right away, but this fraction is one great big fraction. So I'm going to add 3 to both sides first. Absolute value of 12x minus 8 all over 7 equals 4. Now, I would definitely multiply both sides by 7 over 1. These will cancel out. Here we just have 7. So it's the absolute value of 12x minus 8 equals 28. It's equal to a positive 28. I've isolated this. Now I can bust it up into two equations. Everything inside here right now could equal 28, or it could equal negative 28, and it would make it a true statement. So those are the two equations I'm going to set this inside equal to. So 12x minus 8 equals 28, and 12x minus 8 equals negative 28. Okay, adding 8 to both sides, I get 12x equals 36, divide by 12, x equals 3. There's one answer. Here, adding 8 to both sides, I get 12x equals, what do we got, negative 20. Okay, it's not going to be a whole number, that's fine. Negative 20 over 12, if you reduce this, I'm just going to say negative, dividing both by 4, I'd get 5/3. And that answer is fine. You could write it as negative 1 2/3 or negative 1.6 repeating. That would be fine. Okay? So that one's a little bit more complex. Okay, what do we got here? Okay. Lot of work here. We're gonna have to get busy, I guess. Once again, getting that absolute value by itself. Now, here's one great big fraction. I wouldn't add 5 to both sides because that's in the numerator. I'd multiply by 3 over 1, or just 3, right away. For absolute value of 8x minus 16 minus the 5 equals equals 27. And then start breaking it up from here. A lot of people might distribute here. I wouldn't distribute through an absolute value, just get that absolute value by itself. We're going to add 5 first. These cancel out, and I would get 32 over here. And being you're multiplying that absolute value by 4, I would divide by 4. Boom. 8x minus 16, the absolute value of that equals 8. Now it's equal to a positive number. Absolute value is isolated. It's equal to a positive number. You can break it up into 2 equations. 8x minus 16 equals 8, obviously. And 8x minus 16 equals negative 8. So adding 16 to both sides, I get 8x equals 24. Divide both sides by 8. Okay, you're going to get 3 for an answer. If you do the other side, you're going to get 1. It's been real. It's been fun. It's been real fun. If you have any questions, come talk to me.